Assume that we know a nominal rate of interest compounded a number of periods, and we want to compute another nominal rate of interest that is compounded in a different number of periods of times. What to do to compute this nominal rate of interest? For example, if we have this situation, what nominal annual rate compounded monthly is equivalent to 6.4 compounded semi-annually? So we know this nominal rate, 6.4 compounded semi-annually, and we want to compute another nominal annual rate of interest that is compounded in a different number of periods. For example, here it's compounded monthly. What nominal annual rate of interest compounded monthly give me the same future value, the same maturity value of 6.4 compounded semi-annually? What to do in this case? We know the formula of future value. The formula of future value, we know that is future value equal the principal or present value 1 plus I to the power n, when n is the total number of compound periods. And this formula can be written as S equal P1 plus R divided by m to the power n. So this R is the nominal rate of interest and is divided by m, the number of compounded periods. So R divided by m is this I, that is the periodic rate of interest. So how to use this formula to compute an equivalent rate of interest, equivalent to one that we know? So this is the situation. So to solve this idea, so to get a formula for doing that, an idea is to think in the investment of $1, and this invested in 1 year only. So we know that if that happens, then the future value will be 1 multiplied by 1 plus R over M. Obviously, in 1 year, the number of periods will be the same of the number of period that the money is compounding in 1 year. So this N will be the same of M if we are thinking in 1 year. So this actually can be written 1 plus R over N to the power M. And we can use this formula using both interests. So the interest that we know and the interest that we are computing. That is the idea. So in this example, we are looking for a nominal rate of interest compounded monthly. So for this nominal rate of interest compounded monthly, what we have is this 1 plus R over 12 to the power 12. So 1 plus R over M to the power M. And for the nominal rate that we know is 6.4 compounded semi-annually. So $1 will be producing the same, and it will be 1 plus 0.064, this is the 6.4%, and it's compounded semi-annually. We divide it by 2 and get to the power 2. And solving this equation give you the answer of R. So solving this equation for R give you the answer for this R, give you what is the new nominal rate of interest equivalent to this one. So let's do it. So for solving this, we can divide by 12. We are going to solve for R, so we know that the exponent this side is 12. We can divide by 12, both exponents. So the exponent on the left side and the exponent of the right side by 12. Here will be 12 over 12, and here the exponent will be 2 over 12. Let's type it. 1 plus R over 12 to the power 12 over 12 equal 1 plus 0.064 over 2 to the power 2 over 12. Both exponents are divided by 12. Always, if we do that, this exponent will be 1, so we don't need to type the exponent, we don't need to type the bracket. So we can write 1 plus R over 12, and this will be 1.064 divided by 2 to the power 2 over 12. You can write 1 over 6, that is, you can simplify, but it's not necessary. You are going to use a calculator at the end, by the way. Okay, so this one that is written here can be go to the other side subtracting, and then you can multiply by 12. So you can subtract first 1 and then multiply by 12. So you get then that R will be 12 multiplied by 1 plus 0.064 over 2 to the power 2 over 12 minus 1. And then use your calculator. So using your calculator, you get 0.063162989. I already used it. This is the answer. And obviously, because that must be given using percent, you multiply by 100. If you multiply by 100, the answer of R will be 6.3163. So you can use this idea to compute the equivalent rate of interest. If we know one rate of interest, find another compounded in a different period of time using the same idea. You can start from here. Let's make another example. What nominal annual rate compounded quarterly is equivalent to 4.6 compounded monthly? So I start thinking in $1, 1 year, so you can start with this formula, but type in here M, and don't type anything in the principal, it will be $1. So you can type for the annual compounded quarterly, for the nominal annual rate compounded quarterly that you don't know, you can, the answer will be this. That will be the compounding factor for this R that we don't know. And because this R is compounded quarterly, so will be R over 4 to the power 4 here. And then at the other side will be the nominal rate that you know. If you invest $1 at 4.6 compounded monthly, then after 1 year you're going to have 1 plus 0.046 divided by 12 to the power 12. And then solve for R. Solve for R means that you are going to divide both exponent by the one of the right side, the one that of the side when you see the R. So you divide by 4 here, divide by 4 at the other side. If you do that, here will be 4 over 4. That is 1. So you can write 1 plus R over 4 without bracket. And on the other side will be 12 over 4, the exponent, so will be 3. Yeah? So will be 12 over 4. You divide by 4 both exponents. And then after you do that, this side will be just 1 plus R over 4, and this will be 1 plus 0.046 over 12 to the power 3. In this case, we can immediately type 3. We know what is the answer, 12 over 4. Or you can leave it 12 over 4. Okay, so this one can go to the other side, and then 4 can be multiply everything later. So first subtract 1 and then multiply both sides by 4. So you will notice that R will be equal to 4, open bracket, and this factor. With the minus 1, that was the one that was adding at the other side here. And then use your calculator. When you use your calculator, the answer is 0.046175. And then multiply by 100 to type it in percent. So multiply by 100 will be 4.618 here. So sorry, 4.6177. This 6 will becomes a 7. So it will be 4.6177%. This is the nominal rate of interest. So what does it mean? That 4.6 compounded monthly give you the same maturity value if you put the money at 4.6177 compounded quarterly in this case. Okay, with this I finished my explanation of this. I hope you have found it useful. Thank you.